some few things about JPA programming to make sure we didn't miss anything. So for JPA, as you know, the way it works, we come to the class, and then we add annotations to map classes to tables. And then once we do that, we use this JPA programming API to interact with the database. So in the JPA programming, we have a major class called Entity Manager. And we use this Entity Manager to either find a particular object or particular record in a particular table, or we want to store an object in a table using persist, or update an object using merge, or delete basically a table record using remove. We can also use the Entity Manager to run queries. So we have three types of queries, and this is where you need to really pay attention. This is one possible question for your exam. So what are the difference between the three types of queries that the Entity Manager allows us to run? So there is a named query, just a query, and a native query, three types of queries. So a named query, as I will show you shortly, is basically a query that has a name. So you create it, you give it a name. Whenever you want to run it, you create a named query. Create a query, you will create a query using JPQL. So it's a kind of very similar to SQL, but slightly different. So in SQL, you are querying tables. In JPQL, you are querying objects. And I will show you the difference shortly. Create a native query. In here, you are creating an SQL statement, which is written to query tables, not the objects. So just from the examples, let me just super quickly show you an example of what I mean by named query. Here is an example named query. See here, I come on top of my entity and add this annotation, named queries, and I can have as many named queries as I wish. So a named query is just a query that has a name. And then when I want to run this query, I will say entity manager dot create a named query, and I'll give it this name. So instead of putting this query in my code, I put the name of it. And the advantage of this, the main advantage of this, is that this query is compiled, verified by the compiler when you compile the program. So if you have a small error here, for example, you put here orders, or you put here customer or ID, when you compile, the compiler will detect that the class order does not have, let's say, an ID. And it will tell you, it will let you know. Now, if you use a query or a native query, you will not find the error until you run the program. So because the query or a native query is just a string, the compiler will not be able to help you find out what's going on, what's going wrong. So this is the two major advantages. The first one is that this query, you can reuse it whenever you want it. Just call it by name. The second advantage, which is even more important, the compiler can help you detect errors in the query at compile time. Because here, order is not really a table. Order is the actual class. So the compiler knows the structure of that class, the attribute names, and basically, if there is a problem, it will let you know. So, and the way you call these named queries is that you go, here is an example how you call them. So, for example, here, this is a query. This is not a named query. I take the actual query and put it as a string and pass it as a parameter to create a query. And then I run it using getResultList. But the way I run a named query is, you see here, I say create named query. And what do I give it as a parameter? The name of the query that I want to execute. Same. You can pass parameters. Have a look at this. You can do set parameter here. Here's an example. So if I go to this query, it will be under customer entity. This is the name of it. It expects a parameter called customer ID. I pass it the parameter, and then I call get single result or get result list. So if I go under customer, I have here two queries. One of them, it gives me all the orders, order summary, all for all customers. And this one gives me the summary for one particular customer. So it expects, can you see here? Expects a parameter, customer ID. So named query and the query, they are exactly the same. Same capabilities. You can define parameters and set them before you run the query. The only difference is this one, you define upfront, a priori, you put it on top of the entity as an annotation. You give it a name. By the way, this name should be unique in the whole application, globally unique. That's why it's a good idea when you name your named queries as a convention. It's not a must, but people often do it. They put the name of the entity dot the name of the query. This will give you less chances of having conflicts in the names, because the names are global identifiers. In the whole application, if you give another name similar to this, like same as this, you'll have a problem. So it's globally unique. Yes, please. The same. But the only thing when you group, no, it should work. Look, this one fully working if you try it. As long as when you do in group by, of course in here when you do group by, where is group? Sorry, here. You know, in SQL in general, when you do group by, the group by column should be like what you can mention in the select is either the columns that you use for group by. If you mention other columns, you have to use some kind of aggregation function. Sum or max or min. You cannot put other columns. But this is not specific to this. This is the SQL syntax. You know, group by means go and group the records by this particular column or attributes. Yeah, but if you do so, you have to, for the group by column, it can be mentioned directly in the select. But if you want to mention any other column, you must use an aggregation function, like sum or max or min, or yeah, you get the idea. So otherwise, of course, it will not work, because that's how group by works. Yeah. All right. So that's basically the named query. Native query is you use a normal SQL. Now, here you need to be a little bit more careful and try to understand why they came up with this JPQL. So basically, when you use JPQL, which is Java Persistence Query Language, you are basically querying, in your query, you are mentioning the class names and the attribute names. You don't care about the table names. You don't care about the column names. So you, as a developer, you stay in your object-oriented world, and you are querying objects, regardless how they are mapped. Maybe a class is mapped to multiple tables, but you don't really need to care. You are just querying the actual objects of that class. Plus, the JPA will take care of generating the right queries on your behalf. This will also protect you, especially if you are using an application that you want to sell to others, and you give them the freedom to use any other server, any database server. If you use a native SQL, most likely you might use some features that are specific to a particular server. For example, if you use MySQL, you might be tempted to use some features that are only exist in MySQL, and suddenly your application will only run with MySQL. So if you stick with JPQL and put the effort to write your queries in JPQL, your application can run on any database. You are not coupled to one particular database. And this is important if somebody wants to do what is known as off-the-shelf applications, applications that you just buy and use, something like Blackboard or Banner. You don't want to make it linked to a particular database, because the customer that buys it from you, they might want to use MySQL, or they want to use Oracle or SQL Server. You don't want your application to be linked and dependent on one and only one particular database. Okay, so that's why sticking to JPQL, you are safe from this problem of depending on one particular database syntax. Because you know, SQL is standard. Yes, it is standard language. All databases understand it. But every database tries to add some extra features that are not compatible with the standard. So for example, Oracle, what is the flavor of SQL Oracle uses? It's called PLSQL. Okay. The SQL Server, the Microsoft SQL Server, it uses another flavor of SQL called TSQL. So, and each one adds some extra capabilities. But the problem is, if you are trapped and start using these extra capabilities, khalas, your application is coupled and dependent on that database. It cannot move easily to another database. If it is your own in-house application, it's fine, because most likely you will not move to another database. But if you are building something to sell to many other clients, and you want to give them the freedom to choose their database, then JPQL is much better to write all your queries in JPQL. You get the idea? But sometimes you have no choice. You tried and you really want to use some feature that comes with that flavor of SQL. No problem, you can still use native SQL. So you go entity manager dot create a native SQL, native query, and you put in a string the SQL statement. That's why you have how many type of ways you can create a query in Entity Manager? 3 ways. Create a query, you give it a string. Okay, this is important to understand. Let me just show you. This is create a query. What I'm giving it here? A string. And this string is really written as JPQL. This is not SQL. It's very close, but not SQL. Here is another way, named query. I already defined it elsewhere, and I just call it and execute it. And the third way is, of course, you do native SQL, a native query, and you just say create native query, and you pass as a string an SQL statement. Okay, so these are the 3 ways. You need to be familiar with these 3 ways. Okay, so the entity manager basically takes care of taking your objects and pushing them to the database. Or you can ask it to go to the database and fetch some records and make them as objects. Now, really, when you look carefully under beneath the surface, what you will find is JPA uses some kind of in-memory database. And when you read objects, they go to this in-memory database. When you write, you are writing to this in-memory little database. And then when you finish a certain operation, then you can, let's say you have many entities that you are updating or changing and playing with. You can do the changes. They are not reflected in the database immediately. They are reflected either when you call entity manager.flash there's a method called entity-manager.flash. What entity-manager.flash does, this changes in this temporary area are pushed to the database. So this is very powerful. Like you can, let's say you have, let's say hundreds of customers or hundreds of products, and you want to increase the price by 10%, for example. So you can bring all the products, change them the way you wish, and then in one go, flush them all to the database. These are the main methods that we've seen most of them, and the difference between each one. So here is how you retrieve an entity by ID. So you do entity-manager.find. What is the data type of the object that you are getting back, and then the ID that you want to retrieve. So searching by ID is very, very simple in using JPA. Is basically you go entity-manager.find, and you pass it the ID. Only the primary key, yes. If you want other than the primary key, what you need to do, you have to write a query. Select from, and then you put the where clause. In the where you put whatever you want. But if you are looking for a particular entity by primary key, you have a much better way. Of course, this one behind the scene, it will generate an SQL for you. Okay, this is how you push or create a new record in the database. You create an instance of the entity, and then you do entity-manager.persist. If you want to update, this is for remove. For remove, you get a reference, then remove, or you can do delete from entity where an ID equal a parameter. You set the parameter, and you do execute update. So two ways to do it. Either you kind of get a reference to it and then remove it, or you run a delete statement. Either way will do the same. This is for updates. You do merge, and you do merge. Okay. So if you have a method that does a lot of things in one particular method, you are doing many things to your database, like let's say inserting a new customers, inserting a new orders. All those will be done in this temporary area. When the whole method finish, then they will be pushed to the database. But if you are in a hurry and you want to push them as you go, you do entity-manager.flash. This is very important to remember. What I want to say is, look at this. Let's say in here, you see here I'm doing many things. I'm adding a customer, adding an order, doing many things. All these things will not be done immediately in the database. You see this insert data, insert test data. The changes will not be reflected immediately in the database. When they will be reflected and pushed to the database? When the whole method finish execution. Okay? Or if I want to push them immediately, I call entity-manager.flash. Is clear? So basically a method that has multiple interactions with the entity manager, all the changes are done in this temporary area. And when they will be pushed and synchronized with the database, either when the method finish execution, or if you, as developer, you explicitly call entity-manager.flash. That will be pushed. That will synchronize the changes from temporary area to the actual database. Okay? So this is important to understand. So this is the main things that I want you to be aware about the entity manager. The other thing is JPQL. We've seen it. It's called Java Persistence Query Language, very, very similar to SQL. And I already explained we have three types of queries, named query. The other one that is called not named, it's a dynamic query. Which dynamic means you can construct it as a string. You can concatenate strings, you can do whatever to create the query. A named query is static. It's defined, you cannot change it. خلاص, you can only execute it. You cannot change it. But a query, when you say entity manager dot create a query, what does it expect? A string. That string you can construct programmatically the way you wish. So that's why we call it a dynamic query. So dynamic queries, it's not compiled. If there is an error, you will find it when you run the application. Static query or a named query is compiled. In terms of security, it depends. Like it's not. No, but you can also use set parameter. Set parameter is more secure. Of course, if you concatenate, let's say you want to do authentication, and you say select from user where username equal, and you concatenate the username with the parameter coming, then it is not secure. But if you use set param, it is more secure. So even if it's dynamic query, you can have parameters in the dynamic query. So use parameters instead of using pure concatenation. Okay. What I mean here by concatenation, dynamic here, say for example, I want to look up by status, or I want to look up by student ID, for example, in your homework. So you can have a condition there. But still, in both cases, you are using parameters. Okay. So once you create a query, you can run it, or you can run it using one of these methods. Either get a result list, will give you a list of objects, or if you know it's only one, you do get single result. For example, if you are looking by ID or some unique, the where clause, you are referring to a column that is unique. Then you are expecting only one to come back. So better to use get single results. Okay. So either get list of results or get single results. If it is a query that you want to do update or delete, you call execute update. Because you know there are at least two types of queries. There is select queries and update and delete queries. So select queries, how do you execute them? Get result list or get single result. But delete or update, you use execute update. You can also, if you have parameter, you can set the parameter using set parameter. If you want, when you do get single result list, you can set the maximum results. Say only give me the first 10 or 100 or 10 or 1,000. If you wish, you can limit how many records you want to get from the database. Okay? So that's basically the idea of the queries. So here is the named query. I already defined it. I already explained it. You add it as an annotation to your entity. And then it is static, which means this string cannot change. It is globally scoped. This name should be unique in the whole application. Okay? And of course, it gets compiled, and any errors will be reported by the compiler. This is a good thing because you don't need to wait until a runtime to see these errors. The compiler will tell you this column you're referring does not exist in the class, or this entity you are trying to query does not exist, or if there is any mistake in the query, it will tell you. So this is the advantage of this. Dynamic query is you put it like this: select, you put it as a string. It can have parameters, of course, and you set the parameter and execute the query. Native query, here, this is SQL. Can you see here the star? This is an SQL. But even if you are using SQL, you can still benefit from that serialization to objects. You see here, I do create native query, and I tell JPA, by the way, what I'm getting back here will be of type user. And I can still benefit from that auto serialization. So when I get a result set from the query, it gets auto converted in this case to a type user. Okay, but when I create the query, I must tell the JPA, oh, by the way, this query returns objects of type user. Okay, so even with the native query, you still get a lot of benefits from using JPA. All right. So JPQL, it has all the capabilities of SQL. So this is how you select from a table. You just give it an alias, and you do select from that particular alias. You don't need to do dot star. If you do dot star, that's a SQL. Here, you don't do that. You can also have distinct. This is for eliminating duplicates. So this will give you values that are unique, not duplicated. And in here, I'm doing an aggregation. I'm getting the average salary where salary is greater than 80,000. That's another way, but with group by, yeah, more complicated, yes. You can use distinct, no problem. It will give it to you immediately. Yeah. Distinct will give it. Okay, query with parameters, you already know it. Parameters have column preceded by column. You set the parameter, and then you run the query. You can do bulk updates. Bulk update means you update multiple records at the same time. In here, I am basically updating the manager for a particular department. Okay, and in here, I'm deleting all the projects where the employee is empty, which means remove the projects that have no employees.
Why is he using question?
That's another way of passing parameters. Yeah, that's basically in here. You can either have a named parameters, or first parameter, second parameter. It's alternatives. So this is maybe not the best. I prefer the other one, but this is another syntax. If you don't want to name them, you can kind of give them an index.
So one means first parameter?
Sorry?
One means
yes. So here, question mark, I can have here question mark 3, question mark 4, and I can set it 3 and 4. So the same number I put here will be here. Has to be a number in this case. It's an indexed parameters. It's not the best. I think the other one much better. Named parameters is much better. Here is why you use JPQL. Once you do the mapping, you as developer, khalas, forget about database. Just query your entities. You don't need to worry about table names, column names. You just stay in your comfort zone, dealing with classes and objects. You don't deal with database anymore. Okay, it isolates you from mapping logic. If an entity mapped to 3 tables or 2 tables, you don't care. You just query the entity and let JPA generate the SQL. The named queries get compiled. That's another advantage. And if there is any error, it will be reported to you. If you use a native SQL, of course, it's a string, black box. When you run it, you will find if there are errors. And finally, as I explained before, it makes your application more portable. Because less likely if you use native SQL, you might fall into the trap of using features specific to the target database. But if you use JPQL, you have no problem. Your application can move from one server to another, from one database to another without a problem. But if you use native SQL, it's a problem, because there are small syntax differences between, for example, MySQL and Oracle and so on. Okay, so that's basically the main idea. So this I explained all other stuff. So please go through this. If you have any problem, let me know. So inshallah, next time what we will do, I will just open it and show you what is left to finalize this. What is left is the security. Just to give you an idea, what we will be covering. So there is an open source project called OWASP. This is basically an organization called Open Web Application Security Project. Open Web Application Security Project is a non-profit group. And basically what they do is they, every 3 years, so I think 2006, version 2006 is coming very soon. Every 3 years, they basically do a survey and they talk to security experts and they collect from different people what are the top 10 security threats for web applications. And then they document them and they give you ideas how to avoid them. Okay? And they're very well documented. And then in every platform, if you are in Java developer, this is how you should avoid these 10 threats. If you are Node.js developer, this is how you should avoid them. So they give some free guidance. And in every major city, they have some kind of chapter where they give like tutorials and talks and events to make the developers aware of this. So even in Qatar, there is a OWASP chapter. And they do, yes, and they do like, I think last year we invited them in QU. They give 3 hours tutorial on this. So these are the top 10. One is called the injection. Like for example, SQL injection. Injection is basically when you have some kind of interpreter, like SQL interpreter, something that receives a string and run it for you. So the attacker will try to send some commands that you didn't intend and let that runtime engine run it. And then it produces some effects or some consequences that you as developer, that's not what your intention. Okay, and this is very, very serious. Like most of the data breaches that we hear in the news, like for example, this company have lost credit card of their customers, or password has been downloaded, or the whole database has been hacked. This is all, mainly due to injection. So the way I will cover this is I will give you some overview what's the problem is, and hopefully give you some small example, a running example of how it looks like, and then we take it from there.